solvent has certain properties in it. However, when you add solute and make a solution, you can often change the properties. When the properties of a solution depend on the concentration of solute, it is known as a colligative property. Now, there are three major types of colligative properties that you should know. The first is vapor pressure. When you add solute into a solution, most of the time, the vapor pressure of that solution will decrease. In addition, adding solute into a solvent will elevate the boiling point and depress the freezing point. And the final colligative property is how concentration affects the osmotic pressure. Alright, so the first colligative property that you should be aware of is vapor pressure. So when you add solute into a solvent, the vapor pressure will decrease. This is because ion dipole bonds form between the solute and water does not want to turn into a vapor anymore. So you can actually use a formula to show the pressure of a solution. It's equal to the molar fraction of water, or the solvent, times the pressure of the solvent if it was just pure. So what you'll notice is that this will be a relatively high decimal, and you multiply it by the solvent, and you should get a slightly lower solution. And this makes sense because vapor pressure will decrease. So let's do a problem. I did all the math, but let's start over here. The problem says you have 0.5 moles of solute that's dissolved in 275 grams of hexane, C6H14. So you can do the math. You can find the molar mass of hexane, and you can divide it by 275 grams by that, and you'll get 3.19 moles of hexane. Now next, remember, we need to find the molar fraction of the solvent. So what you do is you put 3.19 moles as a numerator, divided by 0.5 moles of solvent plus the moles of hexane. Remember, this is supposed to be total moles. What you'll get is the molar fraction is equal to about 0.86. Next, you need the pressure of the solvent. This will usually be given to you in the problem, or you'll get a literature value. So you do 0.86 times 400 torr, which is the vapor pressure of hexane, and you should get about 346 torr. And this makes sense because you added a little bit of solute and the vapor pressure will decrease by a bit. So the next colligative property that you should know is boiling point elevation and freezing point depression. This means adding solute into a solution will increase its boiling point and decrease its freezing point. Now this makes sense, right? Because when you add salt into a pot of, let's say, boiling pasta, you actually increase the heat needed for that water to boil, so your pasta can boil quicker. Now, freezing point depression also makes sense, because think about how people put salt onto snow to decrease its melting point so that the salt will melt faster. Now, you can actually find the change in temperature of these boiling point elevation and freezing point depression by calculating that the change in temperature is equal to the constant of the solution, times the molality of the solute times the Van Hoff factor. Now, the constant is given to you usually in the problem. The molality is, remember, that's moles of solute over kilograms of solvent, and the Van Hoff factor. Now, this is when you add a solute into a solvent, and solute will disassociate. And the amount of ions that solute disassociates into is the Van Hoff factor. Now, let's try a problem. Calculate the boiling point of a solution that has 375 grams of S8 and 1,250 grams of CCl4. We are given the K constant, and we're given the boiling point of CCl4 of 76.7. So first, let's look at our formula. We have our constant. Next, we need to find the molality of our solute. So we know we have 375 grams of S8. We can divide this by the molar mass of S8, which you can see on a periodic table, and we should get about 1.46 moles of solute. Next, we need to calculate molality by dividing by kilograms of solvent. So we know our solvent is CCl4. Convert 1,250 grams into 1.25 kilograms. Divide the two, you should get 1.168 molar S8. Next, we need to find our Van Hoff factor. So when you drop S8 into water, it actually does not disassociate at all. The ion dipole bonds do not form and the molecule stays intact. So we can say that our Van Hoff factor is 1. So you can see this here. I have our constant, 5.05, which is given to us. I have the molality of our solute, 1.168, and I have our Van Hoff factor, 1. So we get all this, and we can see that the change of temperature is 5.89 degrees Celsius. This is not your final answer. Remember, it's asking for what is the boiling point of the solution, not what is the change in boiling point. So what you need to do is take the boiling point of our solvent, CCl4, which is 76.7 degrees Celsius, add it to 5.89, which is our change we just calculated, and you should get a final boiling point of 82.6 degrees Celsius. Now this makes sense because remember, adding solute into a solvent increases the boiling point of the solution. Alright, so the last colligative property is osmotic pressure, and it can be calculated using this formula. Although it looks a little complicated, let's break it down. First is I. Remember, this is the Van Hoff factor. This is what the solute disassociates into once it's dissolved. C is the molarity of the solute. Instead of using a big M, they use a C in this equation. R is a constant. It is the ideal gas constant. It is 0.08206 moles per liter ATM. And T is temperature in Kelvin. So let's try a problem. What is the osmotic pressure of a solution with 13.7 grams of HCl and enough water to make 0.5 liters of solution? The temperature is this. So first, let's go in order. First, let's find the Van Hoff factor. Well, HCl, we know HCl is a strong acid, so it disassociates into H and Cl. So that's 2 ions. Put a 2 right there. Next, we need to find the molar concentration of the solute. Well, we know we have 13.7 grams. We do know the molar mass of HCl, and we can find that we have 0.37 moles of HCl. We also know that we're making a 0.5 liter solution, so we can divide moles by liters, and we get about a 0.75 molar HCl. So we can plug our 0.75 in next. Next, remember we have our gas constant, 0.08206, and our temperature. So we have a temperature of 18 degrees Celsius, so we need to add 273, because that's how you calculate Kelvin, and we should have a temperature of 291 degrees Kelvin. So you should multiply all of this, and you should get an answer of 35.9. And we need to have a unit, and every time you use the ideal gas constant, the unit will always be in ATM.